So welcome this morning. I'm Roger Barget. I'm General Manager for AWS Robotics. I'm here with Ray Zhu, Product Manager for the service. And we also have some guests from Robotics who's going to be talking about what they've been doing. Let's go ahead and dive in and tell you about AWS RoboMaker. Just to set some context and get used to the AV equipment, which is not working. There's always the old-fashioned way. I'll stand here for a while. Look, robots are doing some incredible things for us right now. These are just some examples from Amazon where we're using them in our fulfillment centers to pick up racks of products weighing thousands of pounds and allowing humans to stay out of these dangerous environments and allow robotics to do the work for us. Primera, which is forthcoming to deliver packages to your house via drones. And robot developers are doing some absolutely amazing and creating things with robots. The robot in the upper left-hand corner is from the University of Washington. It's being made to allow people who are handicapped and in wheelchairs to actually live independently, and it'll actually feed them. Another example is the Leia robot, which you're going to see later today. We also have the Mars open source rover. And roboticists are solving some incredibly hard problems, core to their application, core to robotics. They've got a lot of hard work to actually solve. What's kind of untenable is how much other work they have to do, which is not core to their job. And let's just start at the beginning. Just trying to get your environment set up, get a laptop set up, or a server set up to actually do the actual development and ensure consistency across every member in the team so that everybody has the very same environment. So when you're deploying to the robot, there's no mistakes. I'm going to try one more time to see if this clicker still has woken up yet. Not working at all. Okay. So again, unnecessary work that has to be done. And they have to tackle today an incredibly broad scope, especially if they're starting from a clean cloth. As you may have heard last night, we think of robots as something which sense, compute, and then take action. New sensors are coming out. A developer may want to try different sensors. They often have to write software packages. I remember talking to one customer that said, hey, we got a camera that was supposed to give us 32 frames per second, which would have been sufficient for the application or for the robot we're trying to build. Unfortunately, we're getting about 8 frames per second, and our entire team had to spend about 3 months just getting reasonable output off that camera. So they have to almost write software from scratch in many cases to get the robot to start working end-to-end for every single piece of hardware. It can be a closed platform. A lot of the companies we've talked to have started writing things from the ground up, which basically means you have to invent everything, every software component, which can be very labor intensive. And limited resources. If you want to add any kind of intelligence, you've got to go out and hire somebody with that kind of experience. When you think about actually just setting up simulation, because simulation is so important until you actually have a physical robot to test on. And even then, it's too expensive, it's too slow to actually test on a physical device. I've talked to a number of startups as we were ramping up this service that said, yeah, we're an 8-person startup and we understand the value of simulation, but we can't spare a team to set up simulation. Other companies can't afford the necessary hardware to set up racks of machines to actually run the simulation. And even some of the largest companies say, yeah, simulation actually requires us to expend a lot of capital effort and a lot of human effort to actually keep the simulation machines up and running and current. It becomes an incredible tax that a team has to pay that simply slows up innovation, okay? And this is a huge tax. You talk to people about how much time they spend in robotics, and we start to wonder, where are all the robots? And you start to realize how much work it has to do and how this is stymieing innovation, okay? But this isn't the first time we've heard this. This is actually, we've heard this song before. Almost a little over 10 years ago, a group of students at Stanford University doing research in robotics for their PhDs made the same observation that even as researchers, they were being slowed and that they had to build everything from the ground up. So they started to ask the question, what if we would actually write software to get our project up and running, and we contributed that to open source so that people that came behind us could actually take advantage of it. This led to something called Willow Garage, where For several years, this group was actually contributing open source software for robotics into something which is called ROS, or which is the Robot Operating System, and it's not an operating system. It's actually a piece of middleware that tends to run on top of an operating system. So what is ROS? It's a many-to-many published subscribed framework. And if you think about a robot that has sensors, it has actuators, it has control programs which are processing data from the sensors, taking intelligent action and driving the actuators to move the robot or take some action. This makes perfect sense to have a message bus and have messages being sent from sensors, control programs picking it up and processing it and sending it. So it is a very natural framework for a robot. It's multi-platform, multi-language, so you can pick the language of your choice to work on. It's open source and BSD and Apache. It's extremely popular in academia. It's hard to find a school that I've talked to that is not using ROS to teach and actually not using ROS in research. But the surprising thing to me when I dug deeper into this is how widely it is used in commercial robotics. I went to the ROSCon this year in Spain. I was struck by how many people were doing commercial robots in ROS. We attended CES earlier this year, about 50 startups in robotics, all of which were using ROS. So what was used to accelerate research has been adopted and used in commercial robotics in a very wide number of applications, as I'll talk about in a second. And so what do you get if you actually start using ROS? Remember, a robot it senses, it processes, and then it takes some kind of an action. You can find ROS packages from sensors like LiDAR, FLIR, depth cameras, even the Kinect sensor, so the robot can see and sense. You can find algorithms and packages in ROS in the ecosystem for navigation, for SLAM, so that robots will know where they are in their environment. You have packages for simulation, both 2D and 3D. And the little image on the lower left-hand side I thought is so cool. It was actually a presentation I heard this year at ROSCon where Open Robotics, working with NASA, is actually building a simulator that has the exact same light characteristics and reflectivity of the moon, so they can actually work with NASA for testing rovers and robotics out on the moon. It's an incredibly rich ecosystem. You have debugging tools that you can use to debug your robot. You have logging and testing, so you can actually get the log records off of your robot and see exactly how it was processing it, what messages it was putting on the bus. It's an incredibly rich ecosystem. So where is it used today? You see ROS being used in drones. You see ROS being used in underwater robotics. You see ROS being used in self-driving vehicles, industrial robots. You see ROS being used for robotic arms, in home robots. Even the International Space Station, and one of the talks that was presented this year at ROSCon is about a team that's actually building a new robot that's going up on the International Space Station, as well as education. The TurtleBot is the robot that's featured down below. Almost every academic institution I've talked with is using TurtleBots for teaching robotics. So the short answer on where ROS is being used, absolutely everywhere. So for us, it was a natural choice for actually building upon, and Ray's going to tell you a little bit more about that. But there's been an effort underfoot. So while ROS was created to support research in robotics, it has been embraced by industry. And as industry started to use it, there's been a common set of observations about how to improve ROS. And there's an initiative called ROS2, which I will paraphrase. It's a commercial grade version of ROS, not just for research, but also to be able to put into production robotics. What's the same? You still have all the same structure. It's a message bus. You have nodes. You have messages that get put on the wire. There's publishers and subscribers. But what's new is a middleware interface based on DDS, which is an open standard. It's a layered architecture, has good data security, no single point of failure, and there's a lot more features to it, which you can find on the Open Robotics website where they talk about ROS2. But what's also cool about this is a number of companies have stepped up. Companies you would expect to see in robotics like Intel, Bosch, Toyota Research, Open Robotics, LG, all saying that they're getting behind this and actually contributing source code to it as well, along with Amazon. And so I think this will be, in terms of commercial robotics, the Linux for robotics. So our solution and approach, which we're going to dive deeper in, let's make robotics easy. Let's start with a solid foundation of both ROS and ROS2, so that our customers and developers can tap into the ecosystem of available software packages that's in that ecosystem. Offer a cloud ID to eliminate the startup costs. You should be able to get started within a minute or two. Pull through our AWS services. And I'm talking about that very large, not just our machine learning services, our analytics services, our IoT services. Offer simulation as a service, so developers do not have to provision any hardware, and it will scale, and we can run parallel simulations as well. And simply put, hopefully have productive robot developers. That is the whole strategy for RoboMaker in a nutshell. With that, I'm going to turn it over to Ray to actually take you on a little bit of a deeper tour through the service. This is just not working.
Okay.
Okay.
Thank you, Roger. And good morning, everyone. Super excited to be here this morning to tell you guys a bit more about AWS RoboMaker. So, AWS RoboMaker offers 4 independent yet integrated capabilities. A development environment in the cloud for you to start writing your robotics applications without any setup or configuration effort. Cloud extensions for ROS to bring the power and intelligence of the cloud into your robots. A simulation service for you to run large-scale and parallel simulations with zero infrastructure provisioning or management. And a fleet management service for you to do over-the-air application deployments and updates while the robots are in use. Now, let's look at each of these capabilities a little bit deeper. First is a development environment in the cloud. Now, for developers, and particularly robotics developers, oftentimes you will notice that before you can start writing the first line of the application code, you're going to have to spend hours or sometimes even days to do these tedious setup work to make sure your dev environment is working properly. You're going to have to download the operating system, the robot operating system, the software framework, different kind of toolings to make sure that they are set up and configured properly, and make sure they're wired together for you to start working on your application code. And if you think about it, with a company with dozens of employees, hundreds of developers, or even thousands of developers, these wasted time and effort, they add up really quickly. And what you lose as a result is time for innovation. And RoboMaker Dev Environment is here to solve that problem. It's a cloud IDE provided in the cloud with all the software, operating system, ROS, build tools, pre-installed, configured. You just go to the AWS RoboMaker console, pick the right EC2 instance size for your environment, and mount the right amount of EBS storage. And through a single click of a button, the environment will be up and running in minutes. Everything is up, and you can start writing your application code right away. Here's how the RoboMaker dev environment looks like. In the middle of the diagram, that's AWS RoboMaker's dev environment, and it's built on top of the AWS Cloud9 IDE service so that you get all the functionalities and capabilities you get from AWS Cloud9. As I mentioned, the environment is integrated with ROS out of the box, and you can pull down our cloud service extensions very easily for you to start writing code on. And once you're done with your application code development, you can use the command line tool and bundling tool and build tool come with that environment to compile your application code, upload the code to the S3 bucket, and then you can start running a simulation of these applications, which I will talk a bit more later on with our simulation capability. Next, cloud extensions for ROS. So for all of these customers we've spoken to when RoboMaker was in a private beta program, almost every single one of them would love to add more powerful and intelligent functionalities into their robots. But they couldn't quite do so because there were 2 constraints they were facing. Number one is the local compute and storage power of their robots, which really constrain what they can do locally on that device. And oftentimes, you have to keep the compute and storage resource limited on the local device to have a more cost-effective structure for that particular robot. Second thing is expertise. As Roger mentioned, robotics is an incredibly hard problem to solve. And for you to build any powerful or interesting capability into a robot, that's even harder. Because you gotta have to know all the robotic systems, You gotta have to know how to real-time data streaming, how to analyze these data. You gotta have to know all the different aspects of machine learning, things like speech generation, language understanding, object recognition, or facial recognition. It's extremely hard for a single developer or single company to have all these expertise to do anything interesting in robotics. And RoboMaker's cloud extension for ROS are here to solve these problems. We want to bring the power and intelligence of the cloud into your robots. All of our cloud extensions are written as ROS packages or ROS nodes, so that any developers who are familiar with the ROS framework can easily get these packages integrated into the applications. Today, we have 5 AWS services integrated into the cloud extension for RoboMaker. We offer Amazon Lex and Amazon Poly extensions for you to build natural conversation capability into your robots. We provide Kinesis video streaming for you to do live streaming of the robot. And if you pair that with the Amazon recognition service, you can do very interesting things like facial recognition and object detection. Lastly, we have logging and monitoring capability provided through Amazon CloudWatch, so that you can do near real-time live streaming of telemetry data and logging data of the robot and get these data into the cloud for analysis, so that you can get more visibility into what's going on with your robots and with your fleet. This is an example. I want to show you guys how these extensions work. Top of the diagram, that's the hardware device. That's the ROS application running on the robot hardware. Bottom of the diagram, that's what's running in the cloud. At the center of the top diagram, that's the CloudWatch extension or CloudWatch node we provide from AWS RoboMaker, and it's completely open source. You can just integrate that CloudWatch node into your ROS application, subscribe that node into a topic that has all the metric and login data. That package will automatically pick up these data off the topic continuously and create a secure connection to the AWS cloud and services, and then continuously push these metric and login data into Amazon CloudWatch. Now, the complexity of the CloudWatch service, the API semantics, and how to handle a secure connection and communication with the cloud from the robot device, all these things are taken care of by this CloudWatch extension provided in RoboMaker. So as a ROS developer, you simply download that package, integrate that as part of a ROS application, then you get that monitoring and logging capability out of the box. Now, what's really cool about what we did is for all of these cloud extensions, we actually built a few sample applications to illustrate how you can use these cloud extensions to build very interesting applications and robots. Now, all of these sample applications, they come with a sample simulation job, so that you can actually, right now, you can go to the AWS RoboMaker console through a single click of a button to launch a sample simulation job and to see how these sample applications work in a simulated environment. I highly encourage all of you guys to go and try to play with one of these sample applications after this session. They're super fun to play with. In addition, each of these sample applications is compatible with a hardware kit called TotalBar 3. And it's available online. You can purchase the TotalBar 3 kit, and you can actually deploy these sample applications through RoboMaker onto the TotalBar 3 and see how these applications work in the real world. So that's RoboMaker's cloud extensions for ROS along with sample applications. Next, simulation. As Roger mentioned, simulation is a big deal in robotics, and it's widely used in robotics for testing purpose. The reason simulation is so popular is whenever you have hardware in the loop for your development or testing cycle, it's either costly or very time-consuming for you to test in the real hardware or in the real world. Now, we've heard from our customers, they typically use simulation for 3 main use cases. First is they use simulation as testing tool while they develop the robotics applications, so that not every single developer needs to have a hardware device, And once they have a code update, they can quickly compile, build, and push into the simulated environment and see how it works. This way, they can iterate much faster and have a lot more innovation compared to if they would have to deploy the code and test in the real hardware. So that's the first use case. The second use case is for regression testing. So every time when you have a new software application released onto your robots, you want to make sure that there isn't any regression issues in the new release and make sure your robot application is still robust enough. And customers actually can use RoboMaker simulation to run large-scale regression testing because with the power of the simulation and the power of the cloud, you can spin up, say, 500, even 5,000 simulation jobs with different test cases for a regression testing and make sure that everything works fine. So what's interesting is one of the customers who participated in our beta program, they released a new robotics application onto the hardware every 3 months, which is pretty agile. And out of these 3 months, they need to spend 1 month to do the testing, regression testing, because they did that in the real world case. Their robot operates in an indoor environment, so they got to have to test in different kind of rooms with different kind of layouts, frictions, variance, people walking around, dogs jumping around. So it's really time-consuming for them to do that. And they were really excited by the RoboMaker simulation capability. If you think about it, if we can cut down that 1 month testing time in the real world to a day or 2, the result is that they can have 33% more time to do more innovation and build more interesting capabilities into their robot. So that's super powerful with the simulation. A third use case is for synthetic data generation and collection for customers who wants to build an algorithm, for example, like navigation, that use sensor data as an input. You want to make sure that your algorithm is robust enough so that with all the different kind of noise in the sensor data, different kind of environments, the algorithm still works. And again, it's very hard and costly to collect all these sensor and imaging data from the real world because you gotta have to make sure you collect all kinds of data in different environments, different variance in the environments, and different noise level. So we see customers do that in a simulated environment. They collect these synthetic data from the simulated world and use that for algorithm training or testing purpose. So these are the 3 main simulation use cases we've seen so far. And when developers and customers, they love the power of the simulation, but they do not like the fact that they have to manage and provision all the infrastructure for the simulation. And oftentimes, if you want to run large-scale and parallel simulation, the work you gotta have to put in to manage the infrastructure and scale the infrastructure is not trivial. And that's why we built AWS RoboMaker and make simulation as a service. This diagram summarizes the AWS RoboMaker simulation service. Now, throughout this entire diagram, there's absolutely no server or EC2 instance for you to provision or manage. We manage all these infrastructures behind the scene. On the top right-hand side of the diagram is where you will upload your simulation application and robotics application into an S3 bucket after you've completed compilation from your dev environment. And then you will go to the AWS RoboMaker console and create a simulation job and point us to the S3 bucket. Then we will just run the simulation for you. On the left-hand side of the diagram, we provide a variety of tools for you to interact with the simulation. This is really to enable the iterative development use case I just mentioned when the developer is writing the application code. They can visualize the simulation, see what's going on in the simulated world. They can visualize the sensor data to have a view from the robot. They can visualize the message passing of the ROS application for debugging purpose. And they can also use command line tool to interact with the application while the simulation is still running. On the right-hand side, you can see the capability and integration with CloudWatch for monitoring and also logging capability. And these are really for the regression testing use case. Because oftentimes when you run a regression testing, you want to run 500, 5,000 different test cases for 20 hours, 30 hours, or 50 hours. And you do not want to necessarily staring at these simulations while they're running, which is why we have this metricing and monitoring capability. So you can just say, hey, RoboMaker, run these 5,000 simulations for 20 hours. And 20 hours later, you come back and look at the metrics and see if any of the performance metric data doesn't look right. For those that do not look right, you can actually go to the S3 bucket and take a look at these logs and do troubleshoot, debugging. Once you fix your code, you can run them again. So this slide demonstrates the parallel and large-scale simulation capability. It really demonstrates the power with a combination of a simulation and the cloud, because we have a large amount of infrastructure in the cloud. When you run large-scale simulation, you can spin up thousands of jobs with RoboMaker, and once you're done, you close the job and stop paying for that. The pricing model we use for AWS RoboMaker is absolutely pay as you go. So we only charge you for the number of hours you're running your simulation for, and we measure the number of resources you use so that you'll get a different hourly rate depending on the complexity level of your simulation job. Once you're done with your simulation job, turn off the job, then you stop paying for anything. Next, fleet management. So once you are done with your application development and testing, now you have to get your application onto the real hardware device. Traditionally, developers, they either need to develop a system themselves or integrate with some system out there. Again, we think that's undifferentiated heavy lifting, and what that takes away is very valuable developer time for innovation. So we have thought about that, which is why we also included the fleet management capability in the AWS RoboMaker service. It provides robot registry, security, and fault tolerance out of the box. This is how it looks like, top of the diagram. You will register a robot with the AWS RoboMaker fleet management service. Once you've registered your robots, you will organize robots by creating a fleet and add robots into a fleet. For example, you can have a beta fleet for your testing robots, and you can have a production fleet, which includes all your robots in production environment, so that you can do testing and deployment onto the beta fleet first, and if everything looks fine, then you can move on to the production fleet. So the way you do that, again, after you test the application, you will upload the application into an S3 bucket or use an existing bucket that's already been tested and simulated from your existing S3 bucket. And then you will create a deployment job on the AWS RoboMaker console and select a fleet you want to push the code down. Then we will manage all the secure connection, application launch, and application download behind the scene. And what's nice about AWS RoboMaker's fleet management capability is it is integrated with the AWS Greengrass service. AWS Greengrass is part of the AWS IoT ecosystem. It offers edge computing capabilities. You can do local Lambda function, local messaging, and you can do over-the-air deployment of machine learning models. So with RoboMaker's fleet management, you can take advantage of both the deployment over the air for robotics applications and all the other functionalities comes with AWS Greengrass. So these are the 4 capabilities provided in AWS RoboMaker: a dev environment in the cloud, extensions for ROS to enable robots with the power of the cloud, a simulation as a service, and fleet management capability. Now I would like to welcome Gabriel Lopez, principal scientist from Robotics system, to share with you guys about their innovations in robotics and how AWS RoboMaker can help them innovate even faster. Gabriel?
Great, thank you very much. We're very excited to be here and to tell you the story about a robot that you see right here. So we're a Dutch company, and our mission is to improve the quality of life of elderly by means of robotics. And to tell you this story, I want to show you a movie. And this movie, it's something that you can probably relate to. This is Case. Case is retired. He's a grandfather, and he was diagnosed with Parkinson's disease. This really affected his life because now he's not independent anymore. He needs continuously support and help from his family and his wife. We signed up Case for a trial with Leia, and after a few explanations, he was able to try it, and something really wonderful happened. He was able to walk again. He was comfortable. He was very stable. His balance was good, and was able to become free again. He was independent. And this is the kind of mission that we want to achieve, to give independence to people, to really change their lives. That's the purpose of our company. And we want to do that via robots. There's a lot of potential in robotics to change the way people live. So what is LEA? LEA is the Lean Empowering Assistant. And it has 4 very important features. The first one is autonomy. It's a fully autonomous robot. It can come to you when you press a button, and you can also send it to any place of your home. It actually builds a map of your environment, and it can navigate normally like any other robot that you've seen. But it's also very interactive. The handlebars can detect your intention, and it will walk with you. But it also has other interactive features. You can dance with it, you can do exercises so that you can stay fit, and you can even use voice calling to talk to your family. Now, safety is really important for us. It's really important because users can be very fragile. They can have problems with mobility. So we really put a lot of effort in making this a medical device. So it's certified as a medical device. And it was completely designed from a user-centric point of view. So we designed it to be very intuitive. It doesn't look like a robot, and we don't even call it as a robot. It's built for the user. And what is the technology behind it? Well, it has a lot of sensors and a lot of algorithms to make it feel very comfortable to use, very intuitive. We use more than 70 sensors, LiDARs, ultrasonics, infrared sensors. And the purpose of having all these sensors is for redundancy. For example, suppose you have a glass object on the ground. Maybe the camera can't see it, but the ultrasonic sensor will see it. So you really need this redundancy to make it very safe. We also use low-end CPUs. We want to keep the cost down. So we had to develop very sophisticated algorithms with lots of optimization to be able to achieve reliable software that can handle so many sensors. And all this software was built on the foundations of Linux and ROS. And on top of that, we built a new tool, which we called ROL. And ROL stands for Robotics Language. And the purpose of this robotics language is to simplify, to automate the way we code. The robotics language allows you to create new programming languages, very abstract, that focus on the problem that you have. And then from there on, you can generate ROS1 or ROS2 C++ code. But of course, we had to enable cloud support because there's only so much you can do with the onboard CPU. And the cloud support gives you so many more features that really help the user. I will tell you about that in a minute. So putting all of these elements together, we really achieve end-to-end custom design, all the way from the low-level hardware to the very high-level software. Now, we were very excited to integrate RoboMaker with LEA, and I want to tell you a little bit about that. So the first part is really important, is simulation. As you know, robots are physical. They need to abide to the laws of physics. So when you develop a new algorithm, you really need to test this. And if you want to test it in the real world, it's very time-consuming. So it's much better to do it in simulation. So you can, with a RoboMaker, you can really spawn lots of simulations and really effectively test your algorithms. With RoboMaker Kinesis, you can stream data in real time to the cloud. And you can use this to monitor the sensors and to diagnose the health of the robot on the field. With Lex and Poly, you can have voice interaction. And before we collaborated with AWS, this was the most requested feature of users. Can I talk to the robot? Can I tell Alexa to call the robot to me? And can I tell Leah to go away to another room? Well, this is possible with Lex and Poly. We will never be able to do this ourselves. And then also for deployment, we can use Elastic Cloud and S3 buckets. So with Elastic Cloud, we can host a portal that allows the family and the caregivers to check on the health of the patients, of the users. And with S3, we can deploy updates over the air to the robot. And what is the future? Can we use the cloud in the future? Yes, the cloud will really give us lots of new flexibility. So something very important in healthcare is very precise diagnosis and also personalized treatment. And we cannot achieve these things just with the computation on board. If we are able to stream data, the usage data from the user to the cloud, we can then process this data, analyze it, and really provide precise diagnosis and give personalized treatments so that we can really accelerate the rehabilitation of a patient or slow down the progression of a disease on a patient. Well, I would like now to give you a short demo of how we can use AWS services to help us, and I will switch to a different screen. So what you see here is a picture of Leah, and for us, I told you, safety is really important. It's really important that we are aware of our environment. So we built on the skin many, many sensors that detect the presence of obstacles. So whenever you touch something or if you're close by to something, you will see the image lighten up. Now, there's a QR code over there, and I invite everybody to join and use your mobile to connect to that QR code, and you will see the same image in your phone in a website, and hopefully you will see it highlight too. So with this skin, we can really detect obstacles. Are you seeing can you see it? Yes? Yes. Great. Now, just to finalize, I want to tell you about a funny game we do at work that we use to test if everything is okay. And we call this game, Who Can Give the Biggest Hug on the Robot, okay? And it goes a bit like this. So if it's highlighted like a Christmas tree, it passes the test. Well, that's it for me. Thank you very much. We're going to be at the booth, so if you want to talk to us, we're very happy to share our stories. And thank you very much.
Well, thank you, Gabriel. Super valuable innovation in robotics, and it's extremely inspiring. I cannot wait to see more and more customers using AWS RoboMaker to build more and more valuable and useful robots that can help improve our lives. So just to recap, what is AWS RoboMaker? A dev environment comes with all these software and toolings you need out of the box so that you can start writing your application code right away. The dev environment is also integrated with other capabilities of RoboMaker so that you can start your application development, testing, and deployment through a single pane of glass. Cloud extensions for ROS bring the power of these cloud services to ROS developers, to robotics developers. A simulation service for you to run large-scale and parallel simulations without any infrastructure provisioning or management. And a fleet management service to let you do over-the-air deployment once you're done with your application development and test. Now I would like to invite Roger to come back on stage and tell you guys about AWS RoboMaker's partner ecosystem. Roger.
Is it on, actually? I think as you saw from the demonstration of Leah, roboticists are solving really hard and interesting problems, and they really shouldn't have to be messing around with the software that they have to today. So I want to talk a little bit about partnerships and things that are close to my heart. We are working with Open Robotics as a partner. In addition, we're partnering with First Robotics. For those of you who are unfamiliar with First makes educational programs to learners of all ages. And what's been really interesting for robotics, and as Dawn Bossy told me it's not about kids making robots. It's about robots making future science and engineering leaders. And I can't tell you how many members of my team have kids that are in FIRST robotics and competing. And what's interesting is that FIRST is starting to realize that they'd like to actually start offering contests for students to build software for robotics and actually use ROS and use simulation. So we're going to partner together to actually offer some contests this year around that. In addition, we have other partners, Advanced Robot Solutions and Persistent Systems, who are contributing to the ROS2 effort and other activities. So we're very excited about that. And something I'm really excited about, because some of the most exciting innovation in robotics is taking place in education and research universities. So, and we just signed up MIT yesterday morning, and we're just getting started, and we're making our service and credits for AWS to use our service, to use RoboMaker for teaching robotics, for education and research in robotics, and we'll have even more universities joining us in the future, because again, that's where the action's happening, and we actually want to be able to spread the knowledge of how to build robots to these students. So with that, I want to thank you for showing up this morning for our first session on RoboMaker. Again, if you'd like a t-shirt, a pin, or even come up and talk to us about questions, we'll be here for the next several minutes to talk to you. So thank you very much, everyone.